Yay.
I think it's you and I today, right?
Mm-hmm. Yay. Okay, hi everyone. Welcome to Always Coding, our weekly hacky hour. I'm Komal Devjani, a developer advocate with alwaysAI. And Steve, would you like to introduce yourself?
Yeah, I'm Steve Grisette, and I'm the CTO of alwaysAI.
Hello. All right, so if you've attended Hacky Hour in the past, welcome back. And if you're new, welcome to the community. If you're new to Hacky Hour or new to alwaysAI altogether, again, welcome to the community. Hacky Hours are a pun on happy hour. They're designed to be an interactive session between our engineers, our team, and with the developers in our community. So we can get started. Today's topic is facial landmarks with Dlib and alwaysAI. So what I'm going to do is show you how to get started with alwaysAI, downloading the CLI, and then I'll hand it over to Steve so he can get into a little bit more details about the libraries you can use to build facial landmarking app, some data sets, as well as some applications of facial landmarking. Okay, so with that said, hi Trelon. He just said hello. Okay, with that said, we're going to get started and I'm going to share my screen. I know I've mentioned this every time, but it's really, really important that you sign up for alwaysAI. You won't be able to use the platform otherwise. So what you want to do is just here, instead of dashboard, you will have a login button. You can follow that and actually sign up, confirm your account, and then navigate into your dashboard. So the last few times how we downloaded the CLI was we created a new project, and I'm just going to show you another way to get the CLI. What you want to do is scroll down to CLI install instructions, click install CLI, select the operating system you use. So you can use Mac or PC, which are common, or you can select a different operating system. And as you can see, I'm using a Mac, so we would just click next and then click download for Mac OS. Now, you will get an unidentified developer pop-up. What you want to do is just bypass that by opening it on your Finder. If you're using a Windows machine, you will actually see an opportunity to bypass directly on the pop-up. So hopefully that helped. And instead of creating a project on the dashboard this time, I'm going to show you how you can create it using the CLI. So with that, what we want to do is let's go into this GitHub for facial landmarks with Dlib. You should have this in your email. If not, let me actually post this in the chats. Okay, all panelists and attendees. So now you can follow along and do exactly what I do. So once you're in the repo, you click code, and then you select this web URL. And then you want to navigate into a terminal. Let's create a new one, and I'll make this a little bit bigger. So I'm going to go into my alwaysAI directory that I've set up. And then here we will do a git clone of this repo. So git clone, paste the web URL you just copied, and then it should download. It just takes a couple of seconds. Okay, and we have that. Perfect. So now, as you can see, I have this facial landmark Git repo downloaded. So we're going to go into this. And then as you can see, there's different applications that Steve has created. So we're going to use the real-time facial landmark app. So let's go into it, cd real-time. Okay, and then from here, what we want to do is AAI app configure. And here it asks you to select from a list of projects or create a new project. And this is what I wanted to show you, how you can create a new project using the CLI. So you can just kind of hit the down arrow until you see this red prompt that says create a new project. And that's what we want to do, create a new project. Enter project name, and let's call this facial landmark. And then hit enter. So it seems the project is created and we just want to save it into our local computer. And then from here, you want to just kind of follow the same instructions you would to launch any other app. So we want to do AAI app install. And it says here application has no models, and it's because Steve has created it so that you don't need to add a model. You can just use the app. So now what we want to do is AAI app start. Okay, and it looks like it's working. So let's copy this streamer URL and paste it into our browser. And no, this is not a makeover. It's actually the facial landmarking app identifying key points on my face. So as you can see, you can identify the eyes, the nose, the mouth, eyebrows, and the jawline. Okay, hopefully that was easy to follow along with. If not, feel free to ask any questions. So we're just going to stop the streamer right here. And I'm going to stop sharing. So any questions about what I just shared right now? Sheikh has asked if the session is recorded. Yes, the session is recorded, and I'll send a recorded version right after Hacky Hour. Cool. So if there's no other questions about what I just shared, I'm going to pass it over to Steve. Steve, do you want to take over?
Yeah, I'll go ahead and take over. You have the slides, though, I think.
Yep. Let me pull them up.
Yeah. Can I share my screen at the same time?
No, you can. One of us can share at once. Yeah, but you can take sharing rights at any time.
Okay, we'll go ahead and do that.
Okay, cool.
So we're going to be bouncing a little bit today. So between.
No problem.
We'll go through it. So.
Okay.
All right. So what kind of inspired me to do this? If 2 weeks ago, if you were watching Eric's presentation, and you can go back and take a look at it, he was showing, what we have in our Docker container, everything, and Dlib came up. And so a lot of people said, wow, Dlib's in there, and that's cool and everything. Also too, Eric's always been wanting to take Dlib out because we really don't use it for a lot of things within our core system. So I think to save Dlib, I decided that, yeah, I'll go ahead and do a Hacky Hour and start to show some of the benefits of what Dlib can do for you, and how easy it is to use a system with alwaysAI and so forth. So what is Dlib anyway? So Dlib, and it's at dlib.net for anybody that wants to go there and take a look at it. And I'll bring up the site when I start sharing my screen, we start working. It's a set of computer vision libraries created by a gentleman named David King and his staff. And David's a practicing, working computer vision, very much around machine vision and so forth. And so some of the things that Dlib we'll take a look at it, is called facial landmarking detection. And Kamal has shown you that. It also can do something called correlation tracking. So a lot of times you do object detection, but if you've watched object detection work, it can bounce around from frame to frame, and it's expensive. So correlation tracker will smooth that out and hold it, and then you can set a time based on the correlation coordinates of when to fire that object detector and so forth. But it smooths things out, and you can watch with different types of application. If you're doing any type of autonomous vehicle, let's say you're on a boat or a drone or things like that, you're going to have motion, and this helps handle that motion too, to the correlation tracker. But what these two things all have in common is they use something called deep metric learning. And this is a little different than our convolutional neural networks we've been talking about. So what deep metric learning is, it really is about pattern recognition algorithms and then doing a lot of regression analysis against those. So for data scientists, Dlib is a cool place to be. So if you like I said, if you're a real hardcore data scientist, go over to Dlib. And Dlib also offers some things that we're going to look at in the future here at alwaysAI. So when we start to get to unsupervised learning, Dlib has a lot of the algorithms that can help out, or semi-supervised learning type of things where you're doing a lot of regression and correlation. So the key when you're talking about unsupervised learning and computer vision, one of them is going to be k-means clustering. And that algorithm is well represented here and so forth. So next slide, please. So on facial landmarking, so at the top one was really kind of the inspiration where I was reading through some of the releases that had been done in Dlib, and this was in the past. So if you go to that top one, it'll take you right in, and it will point to the white papers that Mr. King used to implement his algorithms and so forth. It's interesting, and I recommend you take a look at it. But we're going to be focused really on two algorithms today, or two APIs, and one of those is the facial detector that Kamal was just running, the one that detected her face. And again, this is not a convolutional neural network. It's using something called histogram of oriented gradients. And I suggest you Wikipedia if you want details, but it's a feature extractor that's taught to look for a feature, in this case, facial. And then behind it has something called a support vector machine. And what support vector machines try to do is cluster results. So it'll sit there and say, okay, so now this histogram gives me a set of gradients, and or a set of pixels, do these pixels correlate with what I think a face is? So it kind of does a double pass at detecting the face. So that's the algorithm. Again, it's not a convolutional neural network. That's why it said model was absent. But it is using AI to do the detecting. The next thing we're going to use is something called the shape predictor. So now we have the face. So how are we going to find out the landmarks? So what shape predictors do is, so first of all, to use a shape detector, you need something that has common structural characteristics, right? So you can't have all things that are really bizarre, trying to figure out what's what, things like that. So you have to have something that's common. So although faces vary, we have pretty fine structural to it. So we have a nose, we have a mouth, we have a right and left eye, we have eyebrows, so we have a jawline. So so this is a good case to put that shape detector at work. Now, the nice thing about Dlib is they did train one of these already for you within the Dlib shape detector. You can get one that's been trained on what they call the IBUG dataset, and we'll see where those are. And it is and what's nice about the IBUG dataset is basically the people that created this dataset have taken 7,000 plus images and already done the annotation. So you got to remember, when you're doing these annotations on these data sets and you're trying to do one on your own, you have to mark 68 space points on the face. So it takes a lot of effort to do that. But anyway, the great thing about Dlib is they have one that is trained on this data set, and maybe in a future when I've talked to Kamal, and I think we might do this, is we'll go ahead and actually do a training of one in the future. But again, it will be a 68.1. There's another data set out there called the HELEN data set, and it has 194 points. So if you want to go into something like facial recognition in hardcore, it's going to take more than just 68 points. So if you look at some of the commercial facial algorithms that are out there, like your Apple and things like that, those are going to be up around 300 and higher on your annotation points. So should I stop for any questions? I think I should.
Yeah, so we actually have a couple of questions, Steve.
Yeah.
AB has asked, do you
By
think,
the
I
way,
know,
AB's responsible. He's the one who said, "Hey, man, wait, I didn't know you had Dlib." So AB is responsible for me doing this too.
wait, well, this would be probably super valuable for him as well. Then I know we're focused specifically on facial landmark this week, but he's asking, can Dlib also work on non-facial data? So for example, shapes of items, for example, luggage.
Yeah. So again, as long as it goes, AB, as long as it has some type of common structural analysis, and you can use it for those types of things. So I think we'd expect, luggage might be interesting. I'm kind of hedging on that one. But something that has common, because I could see all kinds of variants to luggage. I'd probably put a convolutional neural network to work on luggage, but just because I can think of all the different types of bags out there. Go ahead, AB. I think they're prompting you up on this one, so go ahead.
Yeah, sorry. Thanks for taking the question. So actually luggage is a very bad example. So my point was the shape detection.
Yeah.
Like, is there a way I can see an object, say a top view of the object, and then I can say, okay, this is a hexagon, or this is say, when I see a circle, a sphere from top, it will look like a circle, right? Or if I see, say, a how do you say, a pyramid, then I would see it as like a prism, maybe.
Yeah.
So something like that.
Yeah. So
Or I would see it like a square. Sorry, not a prism. So if I see a pyramid, it will, on top view, it will be like a square, right? So I can normalize it as a cube. So the problem statement I'm trying to tackle here is how I can do efficient packing.
Okay. Got it.
So yeah, that's the question.
So, I mean, there could be, let's say that you had something over the top that had a structure to it, right? Like trays. Let's say you had a big tray and it has compartments in it, and that was consistent. You could probably use something like that. Like I said, it has to have a consistent structure. I was thinking, like, if you had a satellite that's flying over and you saw an airplane, right? An airplane's going to have a fuselage. It's going to have wings and tails. That's the type of thing that you could use these shape predictors to say, boom, there it is. And I do want to add that Dlib does have the tools to annotate and train the data on. So in there too, AB. So you can give it a try, but you just need to have a structure. And so again, it could see those compartments, like I said, and they could vary, and it could be one compartment, and you could use that on some type of detection. I think that's what you're asking, correct?
Yes, thanks. So definitely, so if there's a definite points in any object, then I can, Dlib will be a best candidate for doing that.
Yeah. Like I said, I could think of if you had a satellite and you had it flying up above aircraft and you want to identify aircraft or something like that, it'd be very good for it. Those would be structurally the same. They may vary in size and so forth, but they're going to have a structural appearance that looks the same.
Okay. Thank you, Steve.
Sure. Like I said, AB, you were the one who got this one going, so thank you.
Thank you. No, I was very keen for Dlib on Jetson, which I compiled. I think I posted you a message on Discord, but I'm not getting the performance like the FPS because the capability of Jetson is so better compared to CPU. I'm not getting that inference.
Okay, well, I'm going to I'll run some of the examples today, but they are out of an image library on everything on a Jetson Nano. So when I get to the hands-on portion, that will all be on a Jetson Nano.
Cool.
So, and AB's hitting the right thing. Just to tell people, we're gonna be live with NVIDIA on a Hacky Hour coming up on the 17th, and next week I'll be covering CUDA on the Hacky Hour, and then the week after that or something, we'll look at TensorRT running on stuff. So hang in there, AB. We're going to be getting around on the Jetson. We're going to have a lot of taking a look at the Jetson product line coming up.
Hey, Steve. Thanks for your question, AB. We have another one from David Dotz, and he's asking if Dlib can also work with finger poses. So for example, if you're gripping a tool.
And the answer is yes. That would be quite because fingers have a structure to it and so forth, a common structure. And, you know, you'd have to get your annotation databases. I'm not sure where those are, but I have to assume that people have done that. And then you can use, you know, like I said, they have the annotation tools. They have the training as part of the classes in Dlib, and you could use it for that. And that's actually an excellent example of using Dlib. So hands may vary in size and so forth, but they're going to be structurally, they're going to look pretty much the same. Even some robot hands we've seen, right? So,
cool.
So David, that will work.
And then Steve, did you want to present the last slide as well, or wait to show?
Yeah, let's wait on that one, and let's just dive into what we have. I'm going to assume that everyone followed Kamel, and it's really a small data set that comes down and everything. So I would encourage everyone, let's run the examples together. And I'm going to, as I said, I'm going to be running these on my Jetson Nano today. You know, they'll come back to the screen, but that's where we're going to do execution. Kamel, I think you ran on your Mac, obviously. And, you know, I think when we were benching it in all of our testing before, you know, earlier in the week, it's about 22 frames per second, I think, coming off of that on the system. So we know we have the horsepower on at least the laptops to run this. So let's go ahead and get started. So I'm going to go ahead and share my screen, and hopefully they'll allow me to do that. And I think we've got it, right? Everyone can see Catalina Island.
Yep.
So let's go into the code itself. So I'm going to go into facial landmarks. So if you downloaded everything, you'll see facial landmarks with Dlib, and there'll be a facial landmarks subdirectory. And basically, we've created what I did was create a class for you. And you can do whatever you want. You know, these are up here for you to do. So this is a basic class that will use those two APIs that I was talking about from Dlib, and it will also massage the images and spit out what we need. But let's first go through this the class that we have here. And so anyway, so the class has two input. There's the shape predictor, and that's going to be the database. We've talked about, in our case, we're using the default one, which is this right here. If I go over here, no, please don't show binary. But anyway, so this comes from Dlib. It's up there, and this is the predictor model. And this has been done off that IB database. It's up there, and so we're using that one along with the facial detector. So you look to load that. So if you create your own shape detector, that could be looking at hands or things like that from Dlib, you can run that through this too. And then the landmark set. So we're defaulting to 68, but let's say you went out and you used the HELEN database, or you found a pre-trained one in the HELEN database, then you just put it to what I think it's 194 on that landmark, and it'll work. So this will work for basically any shape detector or landmarking type of system you get out there, as long as it's faces. You would have to do some alteration to some of the code. Anyway, so again, so we bring in the shape that you would enter in the shape detector and landmarking parameters. And then we just simply set up the Dlib, the frontal face detector, which is the boxing and so forth, the object detector. And then the next thing is set up the predictor, which is, again, coming off this Dlib shape predictor API. So now we have those two set up. Now this gets interesting. So when you process the image, it's looking for, so this is grabbing the image either from a file or the screen. You need to resize it. So I'm using our Edge IQ resize tools to a width of 500 and so forth. So you need to do that piece too. Now, as I was benching the system, it performs really well. But what I was noticing, it performed better when you move the image for grayscale. So the shape predictor and the face one work very well on a regular colored image, but it works even better when you go to grayscale. So what I did was go ahead and use OpenCV here, and I've moved the color scale to gray. So I've changed it to a gray image. And then, I'm going to return, since I've resized the image, I'm going to return the image to the original program, and then also the gray image. So, and that will become more clear. I should show you this one too as we flop between these. So what I would have done it down. Well, let me go back. I don't want to get us off process. The next thing we do is we're going to do a detect faces shapes here. So this is going in, and it's going to go ahead and first of all detect the faces, and then go ahead and use the predictor to get a set of coordinates for each one of the faces it finds. So the algorithms will find multiple faces. So if Kamal had somebody sitting there with her today and so forth, it could detect multiple people. Go ahead, if you have a friend or family member, and run that live one, and you can check it out. But it will find multiple faces on this one, and then return the coordinates. So what you get back from the detector is, of course, a set of rectangles, and we're just going to loop through. So you put it through a predictor, and the common term for the coordinates is shape. So I use that one there. So you're going to get the shaping, which are just simply coordinates. And then the next thing I need to do is I need to call this method within it, because the way I work and the way, alwaysAI likes to work is I always like to go to a NumPy base. I know how to use arrays. I know how to manipulate them. So what I do is I take the set of coordinates, and then what I do is go ahead and take those and then put them into a NumPy array where I have X and Y coordinates mapped. So first of all, I go through and set up a set of length of 0 arrays, and then I just start adding to that array once I pre-sized it, my I and my Y parts of the system. So now I have an array of coordinates, and I loop through that for each one of the faces, and then I return those coordinates. Then the last thing is rectangles in Dlib are different than rectangles in OpenCV. And I'm an OpenCV fan. Everyone knows that here. So I basically wrote a little utility to get me around that. So basically, anytime I find that rectangle, I will call this method to give me my X, Y, width, and height coordinates. So basically what Dlib does is gives you the top, left, right, and bottom coordinates of that. So, but I need the width and height. So I get those things and I return them. So any questions at this point in time? I know we're just looking at the class, but the class is going to do most of the work here.
Yeah, and remember, if you have any questions, you can also raise your hand and explain it out, or you can type it, whatever you prefer.
Yeah. So, so on this is the main program that we'll be calling the class that does the work. And like I said, go ahead and change the class as you need to do it. So we go ahead and basically that's just the text for the output, but we go into a try function. And the first thing we do is set what the shape predictor is going to be. And then what we do is instantiate that class that we just went through. We're going to use Edge IQ to go. I have a set of images out there, just it's easier so somebody who's running a Raspberry Pi or something like that, it takes less CPU than when running a live version of it. So that's why I put the images in there, and we'll see how that works. So we go ahead and get the images using our API to do that. And that will find any like JPEG, PNG files and all that within a directory, and it'll allow you to then parse through that directory. This is just print. Print just shows me what images I have in that directory. I'll list them out. We then do our favorite thing, and that's get our streamer. And I'm setting up our streamer for the length of the image path. So how many images are in that? And then just the time in between, I'm setting for 3 seconds. And then I'm going to loop through my image paths and get the images out and use OpenCV to read them in. We went through this, we go quickly, we go through and we did the image processing. That's where I converted to grayscale and changed the width. And then I returned my image, my gray image and my image that's been resized. Then I go in and I find my rectangles and I find my facial coordinates using the method called detect faces and shapes. And I'm sorry if I'm rushing a little bit. Kamel has a hard stop at 3 today. So she told me to reel it in. So,
Hey,
and I will be out on Discord to answer any questions.
Sorry to stop you for a second, Steve.
Yeah.
But we actually have another question from AB, and I think he wants to follow along with the explanation. So he's asking, could you please explain the reason why NP conversion is needed? And he mentioned that he kind of missed it.
So basically, I think it's a comfort level. So I'm trying to get into OpenCV and work, and OpenCV uses the NumPy as its base. So does you could use other types of image processing like PIL and things like that may not scikit-learn or scikit-image, I should say, and they may not need that conversion process. But I'm an OpenCV guy and I want to manipulate it, and NumPy is the base of that piece. So that's why I did the conversion. Is that okay, AB, as an explanation? So it's a preference that I have.
Yeah, he says he got it. So
okay. So that's simply it. So you're gonna always find me go back to my base. On it. So yeah, one tool, hammer nails and hammer screws, I guess that's what happens. But anyway, the rest of this is just to mark up the image. So we're going to go through the image. We're going to convert it into the X, Y, and width and height for the rectangle to draw on CV. And then we're going to go ahead and just, count the faces that we have. Then the next thing we're going to do is loop through the facial coordinates that we've gotten back, and then we're going to put circle points to those. So we're going to use OpenCV's circle piece. And so we get the XY coordinates out of facial coordinate, right? And it's going to draw each point it's going to go through and draw each point on the face or set of faces. We're using a radius of 3. If you want to make the point smaller, you can change that to 1 or 0.9 or whatever. You can make it bigger up to 6, but 3 seemed right for me. The next piece is the color of that circle. And so this is blue, green, red. And so what I've said is make the circle blue. And up here, this is again the color. So I said make the rectangle and the wording on that green. And then the -1 says fill in the circle. So, and so what that's telling the image, what it's telling CV to do is fill in the circle, make it a solid circle. Then the last thing I do is I send it out the data. So I know that's a lot, but let's go through and run the program real quick. And so I'm going to actually have some fun here. So I have my Nano set up. And what I want to do is, and I'm going to show you something. I have a little utility called JTop in there, and I'll put in the thing how to do that. And what JTop allows you to do is manipulate in real time your Jetson product. And next week, like I did, I'll show you everything about this. But because I'm playing with it today, I just want to show you the tool. So I want to go in right now. If you look at it, these processors can go a whole lot faster. And so what I want to do is set the Jetson clocks. And so I'm going to go in and I'm going to hit number 5 on control, and I'm going to activate the Jetson clocks here. And so I'm going to speed up my Jetson. So what it does, it's going to kick in the fan to keep the thing cool. And so it's going to launch its fan. And now if we go back and we take a look at I'll go back on the stats. Now you can see, remember we're running underneath the gigahertz. Now I'm kicking up all the processors. And I don't know, AB, this might help you. And I'll definitely put in I'll send Kamel the notes of where to go and download and install this processor. But now, if you can, I don't know if you can hear in the background, but my Jetson is kicking up and running the fans at full speed. And it's also got the CPU cores. We're going to do a lot of our work now running at 1.4 gigahertz on each one of the cores. And we can watch this execute. So now what I'm going to go ahead and do is then let's work on the project. So I'm going to go into my facial DBs, and I'm going to do exactly what Komal did. And I'm going to do alwaysAI app configure. And I'm going to create a new project. I don't have as many projects on there. I actually delete my projects for demo purposes. So I'm just going to call this facial, I'm going to call it something weird, facial landmarking. And that's still wrong. I really can. Landmarks, I'll call it landmarks. And so then what's neat about this is you actually can set up a project now from the command line, which is the way I work. I'm going to create create my directory. I shouldn't. Okay, so I'm in the wrong directory, so I could see this is going to be a disaster. Should go into facial landmarks. So sorry about that. I wasn't in my subdirectory. That was my fault. Let's go back and do it again. And so again, I'm going to use facial landmarks. And then I'm going to go to a remote computer, and I hope it didn't overwrite my system, but we'll try to see. I'm going to use the save device because I only have one. Yep, there we go. And we'll create our Docker file, and it'll go out. And again, you can see the activity that's going on as it's doing all this stuff with the nano. Yeah, let's create that subdirectory. Sorry. And then you want to go now. Remember how we used to have to do deploy? Well, you saw how we do remote and local. We've gotten rid of the double workflow in this thing. That's what I like the best, is I can type in install now, and it will go out and find that device. So you don't have two commands if you're going off to an edge device.
That's cool. I didn't know that.
Yeah. So we've unified the commands. It's checking the target device, and now it's going to copy out, and it will give me that comment.
Yeah, AB is saying I use the MVP model, but this UI looks awesome.
Yeah, it's really nice. It's a Jetson stats program. You can, the developers out there, and then it gives you all the information. Like if you go to info and you can play with memory, you can set up swaps in live time if you have to do it. It's a great tool. And again, we're going to use it next week and so forth. So I'm just previewing it, I guess. And let's go ahead and do a start. And I'm going to come up here and oops. And see if we are ready yet. And oops, connection failed. Okay, let's try it. Come on, baby. Hopefully I didn't wreck it. No, it doesn't like. Yep, okay, so I know what I did here. So there we go. Now we're right there. Just I have a patience problem. So here you'll watch the pieces go. And then what I'm going to try to do here is as we're going through the different photos, and you can see how well it does, you know, on the different images and so forth. What I think is cool is it picked up the eye images even in the glasses on this. So you can see though that it's not really, it's not hitting the GPU at all. And if you see, this is pretty well cruising at this point in time. So it should work well on a Nano. That's my point on it. If you've gotten the Jetson clock set, and then again, here it is, you've seen all this, but what I really like is the face detector works well. And as you can do, the predictor does, because these are a whole set of different faces. I got these images from our sample app on the age and gender. I pulled them in and there you go on it. So, all right, so I think we have a QA, so I'll stop for QA real quick. And we'll also get the slides back up for the next application we're going to be running.
Okay. Yeah, feel free to raise your hand if you have any questions. And I'm going to get the slide back up.
Ready. Okay. So so those are the two databases, and again, the slides are available. So everyone says, oh, that's great, Steve. Other than doing a makeover for Comal, what else can we do with this system? And actually, one of them is going to be a makeover. But anyway, so landmarking is used, especially on the face side. It's going to be used for facial recognition, head and pose estimation. So people have used it to see things like a driver nodding off, right? So if the eyelids go down, something like that, it can do a warning. In retail, what is a person looking at? So if you're in front of a shelf and things like that, they can start to see where a person is looking. So if you're doing stocking and stuff like that in a store, this could be very helpful to you on it. And I'm sure there's some others I'm not even thinking about. Face morphing. So we've all seen it. So how do you put Hillary Clinton's face on Donald Trump? So facial landmarking is the first step of doing that, or putting Kamal's face on me and me and Kamal's. You can do all those types of things. And face morphing, we're going to do face morphing. Just another thing. Face morphing will be done for Halloween. So we're going to have some fun on Halloween. We've already decided our Halloween hacky. We'll have some face morphing to it and some other things. This is a real one, and virtual makeover. So let's think about the fact that we're in COVID-19 right now. So makeup counters are gone, jewelry counters are gone for the most part. Even clothing and things like that, if we got out of the face into traditional pose estimation, which you can use on this, just trying on different things, makeover patterns, jewelry patterns. This is actually pretty big, guys. And so, I recommend taking a look at that. Then we talk about face replacement. So actually, you can do a wholehearted face replacement. So on that, so not just morph the face in, but do a replacement of it and so forth. And again, we'll probably do morphing and replacement for a Halloween type of hacky hour and have some fun on that. And so forth. So those are just some of the things you can do with facial landmarking. So then the last thing I want to do is, so we can go up a slide, is now, again, sorry, down the slide. There we go. So the last thing we're going to do is get you on the way. How do you find facial parts? And so it's, again, as we said, it's a very common structural thing. And so the landmark points all are part of within a structure that there, from the left eyebrow to the right eyebrow, left eye, so forth, nose, mouth, lips, and then what they call the jawline. And all those points are consistently, that's how, if you're annotating, you'd annotate out each one of your face databases and so forth. So what this allows you to do is find the facial parts, which in any type of application may be the next step. You need to find those lines. And then even if you train on a 68 database for just eye recognition, right? So you would concentrate on those facial points and so forth. So let's go ahead and let me share my screen again, and we're going to go into how to do that piece. So first, let me make sure that I'm in, my Jetson's running hog wild there. And I'm
fun story, Steve. AB created a mirror for his kids during Christmas.
Oh, awesome one.
Yeah, using emotion recognition, and it makes you a Grinch or Santa based if you're happy or angry. That's pretty cool.
That is actually very cool. And so AB, we may have you come in and demonstrate that one if you're willing to on it. So you can, I'm serious, this is the group. And if somebody wants to come on and show something, we are more than willing to do that. So we'd love to see that one. Put you on the spot.
Oh, he wants to say something, I think.
Okay, go ahead.
Yeah. So it was on a big screen. So it's an office. I would love to. I'm locked down at home.
Well, at least give us
I can give you the pictures. I'll send you the picture of what we have. It was like in one big screen, and for kids coming in our office, from the staff, it was very cool. We had a showcase for Christmas. We built a big sledge, and the mirror was one of the things. So mirror had a lot of things. So that had facial recognition as well, like for authentication and edge related, because a lot of projects of OpenCV, like facial recognition, don't go further because of GDPR. So,
Right.
so doing at the edge where we don't store data and still do facial recognition by just storing the not storing the pictures, but it's only storing the encodings of the pictures. So we don't store the pictures, but we'll store the encodings of the pictures. That way we can do facial recognition. So that's what I was using Dlib. So that's why that was the first time I used Dlib, and I was impressed with that.
Yeah.
And but that time I was using a Razor to do all the stuff. I did not have the Jetson at that time. But with Jetson, I was trying to do that. I was not getting that FPS. So that is the discussion I was going through with Eric over Discord. And let's see how it goes. I think over the course of time, as you will be going through Jetson's deep dive secrets, I think I can definitely improve the code maybe.
Yeah, and again, I will go ahead and let's, I will see what happens, and I'll run it against. I'm going to be using it.
I will share the code. I will
Yeah.
share the code with you, I think.
Yeah,
that would
yeah,
be
that
easy.
would be good. And again, I have my my Nano here, and so
Perfect. Yeah.
I will fire up and test it. That'd be a lot of fun. So thanks, AB. Getting back to the projects, we're going to go into this one right now called face part detection. So let's go in, and again, it's going to use that class we did before and the same shape predictor pre-done. But in this one, so remember again, I'm going to emphasize this, it has a common structure to it. So within Python, you have, so we're going to use a dictionary, which is a common thing in Python to use. But Python also has a separate library called collections, which is all about dictionary stuff. And it has another thing called ordered dictionary. So remember how we're finding those 68 points and everything. It's very ordered on what we want to do. So this is why I chose this particular structure to build out. So the first thing I do is based on my points. If you remember that facial thing we saw on the slide, you can go back and look at it. But your mouth is sitting between your coordinates 48 to 68. So you have your right eyebrow. So there's your key and there's your coordinates on there. And so you build out one of these facial dictionaries, ordered dictionaries, and you'd put your components in. So for example, if I had something like AB was using and it had more points to it, let's say it went from 48 on mouth to 100, then I can just put those in and slide it. If it's a finger and you've done a finger thing, you can use this one too to identify the different pinkies and so forth on it, depending on how you lay out that coordinate map. So what I've done here is just basically created an ordered dictionary, which is, as I was saying, part of the standard Python libraries would come with most Python implementations. So on this one, as we go into May, it basically will, you start out the same way. You get your shape detector, which is in the directory, and then you go ahead and instantiate that class that I gave you, and then you're gonna set up into your image folder. Streamers there, right? Everything looks the same as we did before. Then we come down into here, right? Which is now we're going through and we're looping the faces with the face coordinates. So here's what gets interesting. So then we put a secondary for loop in here. And first of all, it looks for the name of what you want to do. You're gonna look for name in the dictionary. And then it's gonna also do IJ, and I just print the name up onto the screen because I like to see what's going on. So it'll get the first one on this, which will be mouth, or however it parses through this. And then it will come up with the IJ coordinates that are part of that. So if we look for mouth, it'd be 48 through 68. So that's my range. And I come in and I clone the image as I'm going through the resized image. I clone it. And then I go ahead and I'm going to put text on the cloned image. So, and show, and the reason I'm doing that, let me step back. And the reason I'm cloning the image is I'm going to do it for each one of the facial. I'm going to parse through the image for each one, and I'm going to write on it. So I have a person's face, and I'm going to identify each one of the facial components. So that's why I clone the image. Otherwise, it gets kind of cluttered and everything else like that. So I clone the image because I'm going to write on it several times. So I got it cloned, and then I'm going to go ahead and I'm going to write the name and set the coordinates up at the top point of the slide, and then I'm going to go ahead and put the facial coordinates on it and then send it to our streamer. That's nice, Steve. So what do? Let's go see that work, right? So once again, we'll come over and we're in the face part detection. I'm going to go ahead and configure. And it should come up, and I'm going to create a new project, and I'm just going to call it part detection. Let's just go do that, part detection. So I'm going to call it that, and it's going to go ahead and write, and I'm going to say, where's my device? I'm going to go remote again. And I'm going to use my saved device, which is going to be my Nano again. And if you haven't saved a device, you can go through device setup. But again, I have a time constraint from the boss. So, and again, you can see how it's moving on the Jetson. So yeah, little activity. And then we'll go ahead and we're going to do the install now. Yeah, you can do deploy if you really love deploy. But it's becoming a legacy parameter. And we'll just have to wait a second. It's checking everything out. All right. Come on, guy. There we go. So it's a little slow because I'm abusing my home network today. So apologize on that.
Sometimes you need that just to get the application going.
So there we go. And let's play around. Ready yet? And it's not quite ready. And there we go. Now it's going to start. So here we go. So there's the mouth. And hopefully you guys can all see that. We'll get it up there. There we go. There's the right eyebrow. Remember, mirror image, people. So and that's, at least to me, left eyebrow. There we go. Right eye. So now you're being able to identify the parts and so forth. And as AB was saying, then you can go have some fun and start to do some more of those advanced type of features and so forth. Very much encourage you guys to check out Dlib. We have all the things. It's got some great things. I do it twice just to show that I'm not trying to fool you guys on different ones. So there you go. All the images are there. Like I said, I stole these from our age and gender detector application, the images. So.
And Steve, I noticed that no one asked this, but can you maybe like talk through how someone might use facial landmarking to build out facial recognition?
So what facial, so on facial, and again, AB probably has more experience. I know of it, I've read, I haven't actually done it, but the first thing you have to do is a technique called facial. So you're gonna get a picture of a person and you're gonna have a stored set of pictures of that person, right? And what you're gonna do is run through and get a whole set of facial landmarks in each one of those. And all those photos have had their faces aligned so that it all looks the same, right? And you go through it. So then you're going to take a picture of that person, and that person, then you'll do the landmarking on that person on the alignment, and it's aligned to your data set. And then you go in and then you do a match to those points, and enough of those key points match up. You say, yeah, it's this person or that person and so forth based on the matching on it. And again, I've only done this theoretically. I've kind of stayed away from facial recognition, but I would love to hear what AB has to say, whether that's semi even right.
He actually shared a facial recognition library on GitHub. Are you able to see it, Steve?
I'm sure if I went over there, yeah. So
On QA.
So he's got it up on Git.
Yeah, it's on the Zoom Q&A section.
Oh, it's on the Zoom Q&A section. Sorry. So where is the Zoom Q&A section? I don't think I see. I think because I'm sharing my screen. But anyway, that actually is an end to that, so that I can look at it. So there you go. Q&A. There we go, right there. Answer saying thank you. So yeah, sometimes, you know, a lot of times people are more advanced than me. So again, landmarking, you know, I did it this last weekend and I had to use Dlib before Eric tried to get rid of it. So that was a main piece, but lots of things in it. So I know that's like a fire hose at you guys and so forth. The code is there. Any other questions? And like, I'd like to know, AB, was I even close to on what you do on facial recognition, or I don't want to mislead people. We may have lost him.
No, he's here.
Okay, there you go.
Sorry, I did not get your question. What is the question? Oh,
I kind of described facial recognition as a person that's only read about it and never done it. So
no, that's perfect. Yeah, you have to create a database of the different landmarks of that. So we call it encodings and store it. And you can take, say, 10 to 15 images of the person in different lighting conditions, different at a distance as well, but only one face in one picture. And then try to extract the encoding, store it in the database, and whenever you extract it on the real-time feed, you just compare it and see if it is matching with one of that, and just try to say tag the basically bounding box and label it, saying that this person is Steve or this person is AB or Komal. Sometimes I felt that it works pretty fine. But if you use a lot of makeup or something, right? So even if I could see like two, so from my office itself, like using two different people, but when they are wearing the makeup, they look similar. So even Dlib gets confused.
Okay.
So maybe.
There you go.
So maybe I think an additional level of, I don't know how to fix that, but I was getting that thing, despite I had a very data set of both the ladies.
Makes sense.
Okay. Very good. Thank you so much for that. I just wanted them because you know, you've practically done it, so that's much better than somebody who's theoretically read about it. So.
Yeah, thanks a lot, AB. Before we log off for the day, does anyone else have any questions? Okay. All right. Well, maybe while you were typing out your questions, I'll just mention some final remarks. As Steve mentioned, we are hosting a webinar with NVIDIA. It's how to accelerate development for computer vision on the Jetson with alwaysAI. So I've also included a link to sign up for that webinar. So feel free to go ahead and register for this. You do need to register to join. It's not just a Zoom link. And join us next week for Hacky Hour, where Steve is going to go through CUDA. And then the Hacky Hour after that, we'll just kind of hear what you guys want to discuss. If there is something specific you're interested in learning about, don't hesitate to email me. I can figure out a way to get it on the schedule. So yeah, definitely contact us, reach out to us on Discord, email me. And thanks so much for joining. We're super happy.
And you know, guys, respond back positively and save Dlib from Eric's cut. All right. Yep. Thanks, everyone.
Yeah, thanks, everyone.